welcome to Math and Startup. Today we'll be dealing with the equation of a tangent to a circle. In one of our previous classes, we already dealt with the equation of a circle, both at the origin and at the point A, B. Now we said that the equation of a circle at the point 0, 0, which is at the origin, is given at x squared plus y squared equals r squared. Whereas the equation of a circle at the point A, B, that means a point that is away from the origin, is given as x squared plus y squared plus 2gx plus 2fy plus c equals to 0. But today we are going to be looking strictly at the equation of a tangent to a circle. It is actually given as x1 plus y1 plus g in bracket x plus x1 plus f in bracket y plus y1 plus c equals to 0. This is the equation of a tangent to a circle. But we are actually on a mission to proving that this is true. And there may be need for you to check up the last video we had on circle so that perhaps it may help your comprehensive capacity in understanding what we are going to be doing in today's class. So follow us as we go on in the class. Welcome back once again. Now our aim is actually to prove that the equation of a tangent to a circle is x1 plus y1 plus g in bracket x plus x1 plus f in bracket y plus y1 plus c equals to 0. But there's a need for us to make a recall of the equation of a circle. So we're going to recall that the equation of a circle away from the origin is given as what? X squared plus what? Plus y squared plus what? 2gx plus what? 2fy plus what? C is actually equals to 0. Then I know you will agree with me that if I take all of this entity to the other side, then I'll be having c to be equals to minus in bracket x squared plus y squared plus 2gx plus 2fy. I believe this does not have any argument whatsoever. But don't forget that we said that it's actually the equation of a line. This is the circle, actually. And I have the center point of my circle. And I have my target. And the target is actually a line that is drawn in such a way to touch just the point on the circle. And I have a line drawn from the center of the circle to bisect my target. Then if this point is given as x1, y1, then what do I have? Then I believe you know, if you follow me well, that gradient is defined as a gradient that is denoted by what? By capital M, and can also be written as your dy dx, the popular guy of calculus, equals to y minus y1 all over x minus what? Minus x1. I believe this is equally clear. Then if I go back to my first equation of my circle and I perform what I call explicit differentiation, the implicit differentiation, I mean to say, then what do I have? I want to differentiate this equation. Let me call it star. I want to differentiate it by the law of implicit function. Then I'm going to be having it to be saying that when I differentiate x squared, I'll be having 2x. And when I differentiate y squared, I'll be having 2y dy dx. Then when I differentiate 2gx, I'll be having just 2g. And when I differentiate 2fy, I'll be having 2f then dy dx. Then when I differentiate c, it becomes a 0. So I'm having this to become a 0. Then I'm going to be making dy dx this subject of formula. And if I do, I'll be having my dy dx in brackets to be 2y plus 2f equals to minus 2x and minus 2g, so that my dy dx, when I divide both sides by 2y plus 2f, I'm having minus 2x minus 2g all over what? All over 2y plus 2f. Then when I factorize the concept, because common to both numerator and denominator is 2, so when I factorize the 2, I'll be having minus x minus g all over y plus f as my dy dx. Then don't forget that I actually make a recall that the equation of a straight line with one slope is given as dy dx equals to y minus y1 and x minus x1. I just did that, if you can still remember. Then I can easily equate both together, since dy dx is this entity, and on this place dy dx is actually this entity too. So what do I simply have? I'm going to be equating both together. Perhaps I label this equation 1 and I label this equation 2. Then I can say that equate equation 1 and 2, such that I have y minus y1 all over what? X minus what? Minus x1 equals to minus x minus g all over y plus f of this form. So then I'll perform a simple mathematical operation or simple mathematical principle of cross multiplying, then doing my simple stuff, so that I'll be having y by cross multiplication minus y1 in brackets cross multiply, and I'll be having my y plus f close the bracket equals to what? Minus x minus g in bracket x minus x1. So do your simple expansion. So what do you have? You have y squared, this times this, plus fy, this times this, minus y times y1, this times this, minus y1 and f, equals to this times this, minus x squared, plus xx1, plus, then this times this will give me minus gx, then plus x, x1g. I hope it's clear. By simple multiplication, this multiplied by this, then this multiplied by this, then this multiplies this, then this multiplies this. Then what do you do next is that let's just do a simple manipulation of saying that, okay, taking all of this entity to this other side, what do I have? I'll be having xx1, are you following me? Plus y1, are you still there? This guy has gone to the other side, then followed by what? And then I have minus x squared, then minus y squared, then minus fy, then minus, plus y1f. Are you still there? Then I have here to be what? Minus gx, then plus x1g equals to 0. So I have successfully moved all the entity on the left hand side down to the right hand side, so that I have something of this nature. I hope you are still there. So on that note, what else do we do? What we do now is just do some simple manipulation of doing something. If you remember, in one of previous video, I stated the law of equation, and I said that the law of equation states that whatever you add to the right hand side of an equation is expedient that you do the same to the left hand side of that equation if you still want to sustain your equality symbol. Otherwise, it changes to inequality symbol. So same thing happens here. I'm going to be adding subtracting some factor from the left hand side, and I'm equally going to be doing the same thing to the right hand side, so that I can still sustain my equality sign. So on that note, I have my x1 plus my y1 minus my x squared minus y squared, then followed by minus, stay there, fy. Then what else do you have is that now what are we trying to do in essence is that we are trying to ensure that a part of this equation is fabricated to look like this. So I'm subtracting minus fy from here as well. I've done that here. Then plus y1, are you still there? F followed by what? Followed by minus gx plus x1g equal to what? Then equal to, what did I add and subtract? I added what? I added minus fy, then I subtracted again minus gx. I hope you are still following. Okay, now as we continue with our simple manipulation, then we want to simply simplify what we have down here. Then we'll be having something of what form? Something of the form, say, xx1 plus what? Plus my y1 minus my x squared minus y squared. Then add this together, I have 2fy then I have minus 2gx. I have added both together. Then I am having what else? Plus what? Plus y1f, then plus x1g to be equals to minus fy and minus gx. So on that note, what do I have? I hope you remember that I can easily factor out minus from here so that it looks like this. It looks like x1 plus y1 minus x squared plus y squared, then plus 2fy plus 2gx, and then in brackets, close the bracket now, plus y1 of f plus x1 of g. Then I can easily transport the guy on the left hand side down to the right hand side, so that it becomes plus fy plus gx, then all is equals to 0. Then if you can recall from the beginning that we said that our c, please note that we said that our c is actually equals to minus x squared plus y squared plus 2gx, then plus 2fy. Then if that is the case, we can easily fix the value of c into this equation because they are just the same. I have just factorized minus from this equation. So that I'll be having my x1 plus y1, then minus, follow me, I said all of this including all of this equation give me c. So I'll have plus c, then plus, when you look at these two equations, f is common. So when I bring out f, I'll be having y1 plus y, and when I consider these two expressions as well, I mean to say, I'll be having g to come out as a common factor, then x1 plus x, then all equals to 0. So I can write it as say that. So in conclusion, I have x1 plus y1 plus g in bracket x plus what? Plus x1 plus f in bracket y plus y1, then plus c equals to 0. Then this gives us the equation of a tangent to a circle. So I've just proven that the equation of a tangent to a circle is sx1 plus yy1 plus g in bracket x plus x1 plus f in bracket y plus y1, then plus c equals to 0. Now, for instance, we are given an example. Say that you are given an example, you are given the equation of a circle to a particular point, and you are asked to solve for the equation of the tangent to the circle. What are we to do? Now, if we are given this question on the board and we are asked to solve for the equation of the tangent to that circle, what are we to do? We just simply go by the formula we have generated so far, and we can easily tackle that question from that corridor. So what are we going to do is that we are going to recall that what? Our x1 plus what? yy1 plus what? G in bracket x plus x1 plus what? Plus f in bracket y plus y1 plus c is actually equals to 0. Then what are we going to say? This becomes our x1, just as this becomes our what? Our y1. Then you know that normally we're going to divide this one by 2 to get our g value, because initially it was 2gx from the normal equation of a circle. So that we just get a single value here. Are you with me? What I'm saying is that in our equation of a circle, we have it to be 2gx and 2fy, but there's no 2 here. So I'm going to divide what we have here. Since this is an equation of a circle, we're going to divide this entity by 2. Divide this entity by 2, then fix in your value of x and y, then you're just fine. I hope that makes sense to us. So what we do is I'll just simply say that what? X times x1 is times 4. So times 4 plus what? Plus your y, which is what? Times y1, which is minus 11. Then plus g, that means your minus 3 all over 2 of your x plus 4 plus your 10 all over 2. Then you have your y minus 11, then minus 15 equals to 0. So we just computed those stuff that way, and you are just, when you finish simplifying this, you arrive at the equation of a tangent to a circle at that point. So I'll be having it to say that 4x minus 11y, then minus 3 all over 2 all in bracket x plus 4 plus 5 in bracket y minus 11 minus 15 equals to 0. So if I multiply all by 2, I will have it to be 8x minus 22y minus 3x minus 12. Okay, then here becomes 10, so plus 10y minus 110 minus 30 equals to 0 by simple simplification. Then what else do you have? You discover that you have this minus this to be equals to what? 5x minus 22 plus 10 will give you minus 12y. Then you have minus 12 minus this will give you minus 122, then minus 152, which equals to 0. So you can say that 5x minus 12y equals to 152, and this is the equation of the tangent to the circle in a very simplified manner. In other words too, let me quickly hint us this, even though it's not meant to be part of the class, and the equation of a normal to a circle is just the same way like we have solved for the tangent to a circle, and the same solution as well. But let me quickly show us how it do perpendicular relationship between a tangent and a normal, such that when you multiply both together it will give you minus 1. So in other words, when we talk about normal, so normal in a simple sense is just saying minus 1 all over what? The tangent in a simplified manner without stress. Then if you remember from what we did initially, we said that our dy dx is given as, when we differentiated the concept of equation of a circle, we got it to be, okay, first of all, I want us to recall that our y minus y1 all over x minus x1 is actually equals to m, and the equation of a circle given as x squared plus y squared of 2gx plus what? Plus 2fy plus c equals to 0, where we got it to be said that we have 2x plus what? 2y dy dx plus what? 2g plus 2f plus dy dx equals to 0, so that we said that dy dx is actually equals to what? Minus 2x minus 2g all over 2y plus 2f, and we landed at saying minus in bracket x plus g all over what? Y plus f. So if you since we said that this guy is our tangent, then our normal, let's just say n, is then equals to minus 1 all over our dy dx of the tangent, which is minus x plus g all over y plus f. So that minus cancel minus, then the normal is equals to what? Y plus f all over x plus g. So when you want to derive the equation of a normal to a circle, then you simply equate both together, because this is actually also the y dx of a normal. So we'll be having it to be equating both together. This and this guy. So I'll be having y minus what? Y1 all over x minus what? X1 to be equals to y plus f all over x plus g, and by cross multiplication we'll be having y minus y1 in bracket x plus g equals to y plus f and x minus 1. Now you can easily simplify this as well, just like we did for tangent, but I will leave this as a brain what? As a brain teaser. So I want to see your solution sent to either the email or the comment section. Thank you for being a part of this class once again. I actually implore that you subscribe, share with family and friends, and do ensure that you drop a comment.